We are starting our unit on conic sections, and in class I showed everybody a cone and took sections of that cone to help them to understand why it's called conic sections. When we let a plane intersect a cone, a right circular cone, we get conic sections of circles, ellipses, hyperbolas, and parabolas. We are not going to go in really a lot of depth with conic sections. We're going to hit the basics of it, and you have already gone into fairly good depth with parabolas in Algebra 2, so we will not be focusing on parabolas. For this first day, we're talking about circles. So I like to think of a circle centered at the origin with radius r would have this equation. That would be a circle centered at the origin. Radius r. Okay. If we shift it to the right or left, we change the x coordinate. If we shift it up or down, we change the y coordinate. So this would be the standard form for a circle centered at HK with radius r. So for example, the center of the circle with this equation, the center would be positive 5, negative 8, and the radius would be 4, the square root of that. The center would be negative 7, positive 2, and the radius would be the square root of 8, or 2 square root of 2. So the equation for a circle with radius 8 at center 4, 9 would be x minus 4 squared plus y minus 9 squared is equal to the square of 8, 64. A circle with center 0, negative 4, and radius square root of 7 would be x minus 0 squared plus y plus 4 squared is equal to the square of the square root of 7, which is 7. Alright, if we are asked to find the center and radius of a circle in this form, we need to change this form to be that form. So we're going to begin by grouping our x's together and our y's together. So x squared minus 6x. Leave a space. We're going to complete the square on that. I'll explain why in a second. And then we're going to write our y's, leave a space, and then take the constant to the other side. So it'll be a positive 11 on that side. Okay, we want to make our x's something that looks like that. So we have to complete the square so that we can get it in that form. So I'm going to add, we already spent some time completing the square in the first semester. I'm going to add half of that number squared. Half of negative 6 is negative 3, squared is positive 9. I am always adding, okay? Since I added 9 to this side, I need to go and add 9 to the other side. For our y's, half of positive 8 is positive 4. 4 squared is 16. Add 16 to both sides. And now we factor. Factor that, and we get x minus 3, which is x minus 3 squared. Factor the y's, and we get y plus 4 squared, and that is equal to 36. So this circle has a center of positive 3, negative 4, and the radius of the circle would be 6. Okay. Similar in class, I let the kids do this by themselves. Group your x's together, leave a space to complete the square. Group your y's together, leave a space to complete the square on that. Move the 15 to the other side, minus 15. half of 10 is 5, squared is 25. So I'm adding 25 to both sides. Half of negative 1 is negative 1/2, squared is 1/4. So I'm adding 1/4 to both sides. Factor this into x plus 5 squared. Factor the y's into y minus 1/2 squared. It'll always be half of that number. And this will equal, this is 10 plus 1/4. 10 is 40/4. So 41/4 would be the that number over there. So the center is negative 5, positive 1/2, and the radius is the square root of 41 over 4, which is the square root of 41 over 2. Okay, let us sketch the graph of this circle. So the center is positive 2, negative 3, positive 2, negative 3. The radius is 4, so from the center I go 4 in every direction. And then draw a circle as best you can. Okay. The center would be negative 3, positive 5. And the center is 5. And then we draw the circle. Okay, over here, the center would be positive 6, 0. Positive 6, 0. The radius is 2. 2 in every direction. Sketch your circle. Okay. All right. I'm thinking of what I need from you in calculus. And in calculus, more often than a full circle, we need to recognize a semicircle. So this is the graph of a semicircle. If I took the circle with the equation x squared plus y squared is equal to 49, and I solved that for y, I would subtract x squared on both sides and then square root both sides. And when we square root both sides, we will get positive and negative square root of 49 minus x squared. The positive square root of 49 minus x squared is the top half of a circle. It's the top half. So it is a semicircle. Centered at the origin. Centered at the origin. With radius 7. The negative would be the bottom half. Still centered at the origin, radius 7. So this is the top half of a circle centered at the origin with radius 7. So it is just the top half. Okay? This would be the bottom half of a circle centered at the origin with radius 6. The bottom half. 1, 2, 3, 4, 5, 6. And this would be the top half of a circle centered at the origin with radius 5. So 5, 5, and 5. Okay? All right, I need you to recognize that equation. That's pretty important for us. All right, so the equation of the semicircle centered at the origin with radius 12, whose graph is below the x-axis, would be y is equal to negative square root 144 minus x squared. The equation of the semicircle centered at the origin with radius 11, whose graph is above the x-axis, would be y is equal to positive square root 121 minus x squared. So just recognize that, know how to get the equation of it. That's pretty important for us. So let's consider this piecewise function whose graph is given. Okay, we want to write an equation for this piecewise function. It has 3 pieces, and I truly, in this problem, I should have said f is composed of 2 line segments and a semicircle. I need to say that because we cannot make that assumption. Even though it looks like a semicircle, we cannot assume it's a semicircle unless we are told it is. Same thing with those line segments. They look linear, but we cannot be certain unless we are told. Okay, so we're going to write an equation for f. So the semicircle is actually the easy part. This is a circle, a semicircle centered at the origin, top half, radius 9. So this would be the square root of 9 minus x squared. That's the easy part. Okay. The more difficult part is actually writing the equation of this line, but it gets easy when you know the process. For any equation of a line, you need a point and you need a slope. Point and slope. Once you know the point and slope, it's very easy to get the equation of a line. So we can pick any point on this line, any point. The easiest one, I think, will be this point right here, negative 3, 0. So I'm going to pick negative 3, 0. I like to have 0 involved, so that will definitely be the easiest one. Now for the slope. This point is right on the line, so we go down 2 over 3. So the slope is negative 2 over 3. To write the equation, we write point-slope form. Y minus the y-coordinate of our point is equal to the slope times x minus the x-coordinate of our point. So that will be y minus 0 is equal to negative 2/3 times x minus a negative 3. We're going to do the same thing over here. So get a point and slope. The point, I'm going to use the point 3, 0. For the slope, I go up 1 over 1, up 1 over 1 each time, so the slope is just 1. Y minus the y, let me write this down for the sake of your notes. So point slope form, y minus the y coordinate is equal to the slope times x minus the x coordinate. Okay, and of course the 0, we don't need to include that. So now I'm going to come and write the pieces of f. So f of x is equal to, I'm going to use a big brace, and there will be 3 pieces because of the 3 pieces here. Now guys, this f of x, that takes the place of the y's. I'm not going to come in here and write y equals. That would be like saying y equals this. That's silly. So you only need it once. This is our y equals. So the first piece is negative 2/3 times x plus 3. And that is valid when x is between negative 9 and negative 3. Negative 9 and negative 3. Okay, now for the semicircle. That will be square root 9 minus x squared, and that is valid between negative 3 and 3. Negative 3 and 3. Now, do I include those or not include them? Well, I included it up here, so I'm not going to include it down here, but I truly could because that is equal. They are both equal, so it doesn't matter if I include that or not. Okay? Same thing with the 3. I think since I set it up this way, I think I'll just include that positive 3 down in my next piece. But since they are the same here, we could go ahead and include both of them. Or I could include the semicircle 3's and not the linear 3's. For our other one, we just have x minus 3. And that is valid for 3, 2, 7. And that's how easy it is to write a piecewise function. It takes a little time, but it's not hard. Okay, one more thing I asked us to do here, and that is to find the area between the graph of f and the x-axis. From negative 9 to positive 7. So I need all of this area over here. Need that area. Okay, so I first see the area of a triangle, and the area of a triangle, I need you to know that formula. Triangle area, the formula is 1/2 base times height. There's also a semicircle. Well, the area of a circle, I also need you to know that. I will not be giving you that formula. The area of a circle is pi r squared. So the area of a semicircle would be 1/2 pi r squared. The area of a quarter of a circle would be 1/4 pi r squared, etc. So this piece right here has area 1/2. The base is 2, 3, 4, 5, 6. The base is 6. The height is 4. I'm going to add to that the area of the semicircle. That is 1/2 pi times r squared, where r is 3. And then the area of this triangle, 1/2. The base is 4, and the height is 4. That slope of 1. Okay, so this will be, clean this guy up, this will be 12 plus 9 pi over 2 plus 8, 20 plus 9 pi over 2. Okay, that was a very brief lesson on circles.